Welcome to The Explainer. Today, we're tackling a huge question. How does an AI actually learn to think?
So how does an AI go from just a big jumble of random numbers to, well, a reasoning machine? It's not like flipping a switch. It's actually a journey with really distinct stages that build on each other.
All right, let's get into it. The whole thing starts by building this massive, but still pretty raw, foundation.
So we're going to walk through these 4 key stages. It all starts with what's called random initialization. And yeah, it's pretty much what it sounds like. Just a bunch of random numbers, zero knowledge. From that blank slate, we're going to build it up step by step into something smart.
Okay, so stage 1, pre-training. This is where the model basically swallows a huge chunk of the internet. It's unsupervised, so no human is holding its hand. Its only job, believe it or not, is to predict the next word in a sentence. You do that trillions of times, and it starts to pick up on everything. Grammar, facts, the very patterns of how we talk.
And the amount of data we're talking about here is, well, it's just mind-boggling. 30 trillion tokens. A token is basically a word or part of a word. To give you some perspective, that's a huge leap from the 1.4 trillion used for the very first Llama model. This colossal pile of data is really the base layer.
So, what do you get at the end of all that? You get a powerful, super knowledgeable, but kind of raw base model. The problem is, it's not very useful for a conversation. It's like having this giant library with every book you can imagine, but there's no librarian to help you find what you're looking for. It's just there.
So, how do we make this thing helpful? How do we add the icing on the cake?
And wow, look at the difference here. On the left, the base model, you ask it a simple question and it just kind of spouts out nonsense, like it's trying to complete a random sentence from the internet. But on the right, the chat model, it gives you a perfect, helpful answer. So how do we bridge that gap?
This is where supervised fine-tuning, or SFT, comes in. This is the stage where humans step in and basically teach the model how to be a helpful assistant. We give it thousands of really high-quality examples. Here's a great question, and here's a perfect answer. It's not learning new facts, it's learning the style of a helpful conversation.
All right, so now it's helpful. But how do we get it to take that big leap into real reasoning? This is where we add the cherry on top.
AI legend Yann LeCun had this great way of putting it back in 2016. He said, pre-training is the cake, supervised learning is the icing, and reinforcement learning, that's the cherry on top. It's that final crucial piece.
So what is reinforcement learning, or RL? It's basically a way of training through trial and error. An agent, which in our case is the AI model, tries to do something, and then it gets either a reward or a penalty. Pretty simple, right?
A perfect way to think about it is a game like Pac-Man. Pac-Man is the agent. His actions are moving up, down, left, or right. When he eats a dot, he gets a little reward. When he hits a ghost, big penalty. The goal is to learn the moves that get you the highest score.
Okay, so rewarding the right answer. That's easy to picture for Pac-Man, but how on earth does that work for a language model that just talks?
Well, for an LLM, the environment isn't a maze. It's the huge space of all possible answers it could give. And the reward doesn't come from eating dots, it comes from a reward function that we create, which scores how good its answers are.
Take a super simple example. What is 2 plus 2? If the model says 4, boom, big reward, plus 100 points. If it says 5, well, that's close, but nope, 0 points. If it says something totally random like A, it gets a penalty. We're training it to know what a good answer feels like.
And the model does this over and over for millions and millions of questions. Every time it gets a score, it tweaks its own internal wiring to favor the thought processes that led to the high scores. It's literally learning to chase the reward, which means it's learning to find the correct answer. What's really cool is that this is getting way more efficient. There are these new algorithms, like one called GRPO, that are making a huge difference. Instead of needing a whole separate AI just to be the judge, these newer methods are smarter. They have the model generate a few possible answers, then they just pick the best one from that batch and reward it. It's way faster and cheaper, which is a huge reason we're seeing so many powerful open-source models lately.
So, what's the big takeaway here? What's the next jump?
Well, here's where things get really interesting. The big insight from a lot of recent research is that reinforcement learning, it might not actually be teaching the AI totally new skills.
Yeah, this quote from the DeepSeek paper puts it perfectly. It says, Most likely, the model already has these reasoning capabilities, and we just need to accentuate them. Think about that. The abilities were already there, hidden in the model after that massive pre-training phase. They were baked into the cake all along.
So this whole journey, from raw data to rewarded reasoning, it's all about turning hidden potential into something real and powerful. We're not creating a mathematician from scratch in that final step. We're taking a model that already saw all the math on the internet and just showing it how to act like a mathematician. Reinforcement learning is the key that unlocks the knowledge that was already inside.
And that leaves us with a pretty mind-bending question, right? If a clever system of rewards can teach an AI to reason, what else can it teach it to do? What other incredible abilities are just sitting there, latent inside these models, waiting for us to figure out the right reward to unlock them? That's the question that's driving the whole field forward.